All right, friends and neighbors, time now to sort of finish up DNS and finish up our discussion on resolvers, name servers, and the protocol. And this is part 2 of 3. Now, we've already talked a little bit about the query process, and we know something of the tree and name servers. We've talked about authoritative, non-authoritative. We talked about what caching is, but we're going to sort of wrap all that stuff together. But what we need to do is add 2 more terms, and that is a recursive query and a non-recursive query, or an iterative query. So really this comes down to where the load is placed on the system. And as we see here, the simplest mode for a server is non-recursive or iterative. And so what this means is that the server is not going to do any extra work if it doesn't know the answer. Now, this is as opposed to a recursive query where the server will do a lot of work to try and find the right answer. So it comes down to something like this. A client asks a question, hey, what's the address that goes along with this name server? And if this particular name. And it asks the name server that question. But if the name server doesn't know, it has a choice. It can either say, well, I don't know. But here's somebody that might. Or the name server can say, well, I don't know the answer, but let me see if I can find out for you. And what this does is instantiates this sort of search up the tree and then back down again to try and find the right answer. And so the name servers are working together to try and find the answer, because as we know, no name server has all of the answers. So all name servers must implement non-recursive queries, meaning that they're not going to do the extra work. Now, it's optional then to turn on recursion for the server. So the server, and this is the case where the server says, I don't know the answer, but let me see if I can find out. So that's why it's optional, because you're asking the server to do a lot of extra work. And you can sort of imagine that a busy name server is not only trying to answer direct queries, but now trying to find answers to queries that it doesn't have either cached or in its zone files. And this slide just reminds us of our basic configuration, right? So on the left-hand side, we have how the client is used. So we have some user program, and in this case the user program is something like FTP or a game or chat or a web browser or a mail client, and that client program is causing a DNS query to be made. And of course the thing on the client that makes the query is the resolver. A resolver can do this a couple of ways. It might have a cached entry, right? There might be something that I already have stored locally, and so I just look it up in what I've already learned. But I'll say it now, and I'll probably say it again later on. There's a time to live associated with each record that you're storing. Okay, well, I could also query a name server, which is this whole foreign name server. Now, this could be a local name server too. Foreign just means that it's not my name server, or I might be querying somebody outside of my domain. And then on the right hand side, we have the basic name server configuration, where we have our name server files, right, our zone files, and we have the name server process, named or bind, and requests come in from a resolver, either a local resolver or a foreign resolver, and we get a query and then we give an answer back. So that's pretty straightforward. We also know that, or maybe a reminder would be that when we have zone files, we are the authoritative server for that particular domain. Now, the minute we have more than one server in a particular domain, right, a primary and secondary, or a primary and a backup, then we're going to have another type of record that we're going to use, and that's the transfer record, the transfer record, and that's the zone files. And so if you actually saw a transfer of a zone file, it has all of the records that are in a particular zone file. And sometimes we make a distinction about what kind of client we might have, right? If we have a full resolver, then we have a cache. Most clients will cache something. And then we can make a request of a name server, and that's in the upper right. And then in the bottom, if you have no cache, no storage for answers that you've received, then of course you got to go to the name server every time, or a foreign name server. And again, foreign name server just simply means that it's not in my domain and it's not the name server that I usually go to. Now, if we look at the language of RFC 1034, it describes the terms recursive and iterative in the following way. The 2 general approaches are the recursive and iterative, and we know now that the recursive is more load on the server. Why? Because if the server has a query that comes in, and it doesn't know the answer, then what it's going to do is send requests up the chain and try to find answers to the query for you, and then give you the eventual answer back. Iterative is the opposite. This is the load on the client, where the server says, well, I don't know the answer, but here's a name server that might. And so it's this chain of name servers that the client might have to go through to find the answer. Now, there's advantages and disadvantages to both, but essentially what we have to think about is where the load is, with recursive being load on the server and iterative or non-recursive being the load on the client. And now, just as a reminder, the default configuration or the recommended configuration when you're first messing around with the DNS server is to make it non-recursive. So in named.config, we actually saw that as one of the options. Now, this is sort of a long exchange for how a full-blown process where nobody knows the answer might go. So we start down here at the bottom. This is number one, right? The client machine. So the client machine wants to go to www.nssa.rit.edu. Now, we know at this point that that might not actually be a machine, right? It might actually be a website, and that might be a canonical name for something else. But we'll put that aside for a second. And we can see here at the beginning, right, that each client knows the IP address of a DNS server. You can't be active on a network if you don't know at least one name server. You can't resolve any IP addresses and names. So the client's server comes back and says, well, I don't know that answer, right? So the client's name server doesn't have a cached entry, and so it has to go up the tree farther to try to find this name. And so we can see that this query is moving up the chain. And so now, because it comes from the server, we know that we're looking at a recursive server. Now, the root server might not know the answer either, or what it might simply do is say, well, I know that there's a second level domain server out there that knows all of the .edus. We send it over here to that particular server. Now, a lot of the root servers are going to know all this information, but that's kind of beside the point here. So the IP address of the server for .rit.edu comes back. Now, we know that when we look at a URL like this, or a host name, an FQDN, that we might be looking at not only top-level domains, secondary-level domains, but also subdomains. And so there's no telling where the authority actually is and how far down we have to go. Now, we can sort of guess, right, when we look at this number of labels here. So as we follow this example, the server for rit.edu comes back. And then the server that was originally queried, really whoever it is, says, well, we don't know the answer, but here is a server that might. And then that's passed down to that server that has everything for rit.edu. But rit.edu might not know all of these subdomains. In fact, there's a good chance that there's been this delegation of authority, this registration for the server downstream. And so this is passed even further to that server that might be closer to that particular domain. And finally, down here, we get the server for nssa.rit.edu, and this is an authoritative server. And again, this example assumes that nobody has a cached entry, nobody knows anything. We'll see later on what that actually looks like. And then the answer comes back. We have an IP address, and eventually this gets passed all the way back to the client. So that's how the whole process would work if we weren't storing anything, if we didn't have, additional information that was able to be provided to the client that would sort of subvert this whole process. But that would be the full-on, nobody knows anything, we've got to go right to the source for this. So again, for iterative, if the contacted server doesn't know the IP address, then what we're going to do is we're going to give the client the IP address of the server to look up, and then the client will actually do that process. That's not what we just went through. What we just went through is a recursive lookup, where the client doesn't do a whole lot of work. It just says, I need this IP address, and then all of the servers will get together and figure out the answer. Now, not all servers will want to do recursion. You can sort of imagine that if you've got a busy server, that might not be something that you want to do. And one of the last notes on this is one of the places that we see no recursion being done is on those root servers. Root servers don't want to do a whole lot of lookup. Root servers don't want to do a whole bunch of extra lookups on behalf of the clients. When you get an IP address from a name server that says, here's another name server that you might want to query, that's called a referral. And so root servers only give referrals. So there's an additional term. When you're doing recursion and the answers are coming back or the servers are figuring it out, they're handling it. If they're not going to handle it for you, they'll give you a referral. And here's just another way to look at what a recursive query looks like, right? The resolver says, do you have the answer for me? And what happens is we go to the servers and the servers just keep bouncing back and forth with the answers that we might need. Okay, that'll about do it for queries. So we've got the tree, we've got name servers, we've got resolvers, we've got query types, we've got authoritative versus non-authoritative, we've got root zones, we've got authoritative subdomains, and we've got caching versus non-caching, if I didn't already say that. So this has been that discussion. We're going to polish this off with protocols. But before I get there, let's take a quick look at some of the packet traffic that we're looking at to sort of hint us where we want to go. So here is a quick query that I did for www.rit.edu. You can see that here at the top. Now a DNS message has really three parts to it. Two, if you want to say that queries and answers are the same thing. We have first the beginning part of the header and the flags portion. Now a good question is, when you're getting an authoritative answer, how do you know? Well, right up here we have all of the flags that tell us what's going on. We also have this ID that becomes really, really important to us. We'll see how that goes. And then here is the query and answer section. How many records are we talking about? And then finally we have the query, which actually has a very particular format associated with it. When we get an answer back, right, then we're interested in the flags portion again that tells us whether or not we're getting an authoritative answer and what the server is willing to do. So here we see that this is not an authoritative answer, which means it was probably cached. And then the client has said, well, the server is saying, hey, you wanted recursion. I'm willing to do recursion if I need to. And then here are the answers that I have. Now what's fun about this is that the original request was for rit.edu, but it's a website, and a lot of times websites are CNAMEs. There's no actual machine called www.rit.edu. That's actually this machine here. This was a CNAME. And so what does my client turn around and do? It says, oh, well, I better look that one up to see if I can get an answer for that one. And then the answer comes back. Okay, so that's just a quick look at some packet traffic. We'll cover it in greater detail because all of these fields have a particular meaning. When we're looking, whether we're looking at the straight up query, which is really simple, right? It has the header here and the number of questions, pretty straightforward. And then what kind of question am I asking? And then the answer, which comes back and is a little more complicated. So next up will be the protocol, and that'll close out DNS for us. Thanks for watching. Thanks for listening. Like and subscribe if I helped. And hey, whether you're doing iterative or recursive, may those queries always reach the right name server so that you can always get your answer.